Well, I'm excited to be back in Blue Pen Land.
I'm excited to be back in Blue Pen Land too. It's time to do some net force problems.
Yes, we are going to do that. So the key concept here is that we're going to be dealing with F equals ma, okay? But sometimes there's more than one force acting on it, okay? So what we're going to do with these problems is we're actually going to add up all the forces and set the sum of the forces equal to ma.
Yeah, it's all the forces together. Once you find out all the forces, then you set it equal to ma.
So let's look at this thing here. There's 17 newtons of force of friction, right? There's a 20 kilogram box in the floor. If we look at all the forces acting on it, one of the forces is the force of gravity, right? So the weight of this thing is m times g, right? So it's 20 times 9.8, right?
But that's offset by the force of the tabletop pushing up on the box, because if you didn't have that, then the box would be sinking into the table.
Is that 196? We don't need a calculator, do we?
It's pretty early in the morning.
I know.
It is 196.
So 196 newtons is down, and what Mr. Duggan was saying is that the job of the table is to push 196 newtons up, right? So this is gravity. This is the table, right?
We also call that the normal force. But those things cancel each other out, so they're not going to factor into this particular problem.
And then let's suppose I'm sliding this thing to the right, and if I slide it to the right, then there's a force of friction this way. Ooh, look at that. That's a very straight line, right? If I slide it to the right, then there's a 17 Newton force to the left, okay? Now, if I exert the same force this way, let's suppose that's identical, right? If that's 17 newtons to the right.
If we have 17 newtons to the left
and 17 to the right,
then it can move.
You can move at a constant speed.
Constant speed, not speeding up.
And if I exert more than 17 newtons, there we go.
Then it'll start to accelerate.
Yeah,
to
so
the
let's say I exert 20 newtons this way, right? Then it would actually go faster and faster to the right. So let's quit talking about this and let's do a problem.
Let's do it.
Yeah, there we go. Okay, so there's a 17 Newton force of friction between the box and the floor. It's sliding to the right, and I exert a force to the right. What is the acceleration? Okay, so let's do 78 newtons to the right. Lots of force, right? And if it's sliding to the right, then there's a 17 Newton force this way. So our forces are 17 newtons, 78 newtons.
78 newtons.
Now, when we do F equals ma, F isn't 17 or 78. It's an intelligent combination of them, right? So let's make to the right positive. That makes this force positive, this one negative. And now the sum of our forces is 78 minus 17.
Minus 17, because they're vector quantities.
Equals 20
times A.
And this is an unknown acceleration problem.
So 78 minus 17, that's going to be 61.
Okay.
That's going to equal 20 times A. And now we have to divide both sides by 20. And so the answer that we're going to be looking at is 3.05. But if we want to be fair about it, we've got 17, 78, and 20. All these things have 2 digits. So we should probably round it to 3.1 meters per second to the right. So it's going to be going faster to the right.
Yeah. And this is example number 1. So if there's more than one force, what you do is you set up a system where one direction is positive. You set up F equals ma, and F is the sum of the forces, and then you just solve for A. So subtract or add or whatever you need to do, and then just solve for A.
I hope you have this problem in your notes now, boys and girls.
There you go.